The correlational research is a kind of research in which you measure the relationship between two or more variables, and the correlation is the statistical value that measures the direction and the degree of the relationship between those variables. But you gotta know that we have different types of correlation coefficient depending on what kind of scale is used in each variable. So if both variables are numerical, you use Pearson correlation. However, if one variable is numerical or quantitative, but the other one is ordinal or nominal, then we use different type of correlation coefficient. Regression is another index that's used in both inferential and descriptive statistics. Basically, regression is used to make prediction based on correlation. So whenever a linear relationship exists between two variables, it's possible to make an equation of a straight line that could be used to predict individual scores on one variable based on his or her score on the other variable. And this is a scatter plot, as you are familiar with, that shows the distribution of scores on both variables here, the weight and the strength. As you see, all these points are forming sort of a straight line. This line is called regression line. So the regression line is also called the line of the best fit. As you see here, if I ask you which one is the regression line, obviously it's the blue line because the scores are closer to this line than the other ones. Regression equation has the y and x in it, and y is your criteria and x is your predictor. So if you have your participant score on x, you can predict his or her score on y. There is another formula for regression that's based on z-score or standard score instead of using the raw score. Sometimes we have to use multiple regression when we have multiple predictors. For example, if you want to predict students' success in college and you have multiple predictors like high school GPA, SAT scores, parental education, and some other predictors, you need to use multiple regression to see which of those predictors are better or stronger in terms of predicting student success in college. Now we switch to inferential statistics, where the focus of this chapter is all about. In order to understand inferential statistics, we have to understand what is sampling error. This figure shows you we have like a population of 1,000 college students, and we select two samples, so like two samples of 5 students. As you see, the average age, the average IQ, and the percentage of male and female in the population and in those two samples are given. Although the sampling is random, as you see, the average age and the average IQ is not the same in those two samples. That's what we call it, sampling error. In inferential statistics, our main job is to see how the difference between two samples is due to random error or sampling error, and how much of the difference is difference in treatment. For example, if you have two samples and you have one group to watch violent TV and the other one use like the non-violent TV, and after a couple of months you measure their aggression or aggressive behavior, and you see the difference, like here is 3.4 and here is 7.6. So the question is, the average is obviously different, but how much of this difference is due to sampling error and how much of it is real? It's due to our difference in treatment. In order to answer this question, you have to understand that sampling error is always there. When you're dealing with samples, you always see a difference. But in this particular situation, we want to see this 4-point difference is actually random error or sampling error, or it's due to a different treatment. In order to answer this question, you have to do some hypothesis testing.